Good morning, everyone. Let's start Maths Grade 6, Chapter 5, Prime Time, Subtopic Common Multiples and Common Factors. Learning Objectives. After this session, we'll be able to define common multiples, differentiate between common multiples and common factors, solve problems involving common multiples and common factors. Let us see Idli-Vada game. Children sit in a circle and play a game of numbers. Players take turns counting in order 1, 2, 3 and so on. For multiples of 3, children have to say idli instead of the number. For multiples of 5, children have to say vada. For numbers that are multiples of both 3 and 15, they say idli-vada. So let's see how children will start. Number 1 will start with 1, 2, idli, 4, vada, then idli, then 7, 8, 9 idli, vada, 11 idli, 13, 14 idli vada. So here idli vada is a combination of the multiples of 3 and 5 and idli is the multiples of 3. If we observe here, wherever 3 we can write it as 3 into 1. Similarly 6 we can write it as 3 into 2. So this is a multiple of 3. 9 3 into 3. 12 3 into 4. And vada here 5 multiples of 5 into 1 plus 10 can be written as 5 into 2. Idli vada here this is multiples of 3 and 5. Let us see a question, figure it out. At what number is idli vada is said after the 10th time? Solution. According to the game rules, idli vada is said for multiples of 15. So numbers that are multiples of both 10 and 5. So the multiples of 15 from 1 to 150 are 15, 30 and so on 150. Therefore, the 10th time idli vada is said to be at 150. If they ask for the 20th time, we need to multiply 50 with this 28. The answer will be 300. Similarly, they will be asking on this 100th day. So 15 into 100, 1500. Let us see question number 2. If the game is played for the numbers from 1 till 90, find out how many times would you see children will say idli, including idli vada. Let us see. So the multiples of 3 from 1 till 90 are 3, 6, 9, 12, so on till 90. So if we count these numbers, the count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So therefore, this is the number of times the children would say idli is 30. Instead of this one, we can directly use 90 divided by 3. That is nothing but 30. This is also a shortcut method. Second question. How many times would the children say vada? Similarly, the multiples of 5, 1 to 90 are 5, 10, 15 and so on till 90. So the total number of times the children would say vada is 18. This is nothing but 90 divided by 5, which is 18. How many times would they say idli vada? Answer is 6. The multiples of 15 are 15, 30, 45, 60, 75 and 90. This is the number of times the children would say idli vada is 6. Nothing but 90 divided by 15, which gives us 6. Question number 3. What is the game was played till 900? How would your answers change? Number of multiples of 3 from 1 to 900 will become 900 divided by 3, 300. Number of time multiples of 5 from 1 to 900 is, it will become 900 divided by 5, 180 times. Number of multiples of 15 from 1 till 900 is 900 divided by 15, nothing but 60 times. Let us see question number 4. In this figure, somehow related to the idli vada game. In They have given, imagine playing the game till 30, draw the figure if the game is played till 60. Yes, the figure is related to Idli-Vada game. The figure, if the game is played till 60 is going to be here. We have written here. On this left hand side, multiples of 3. 3, 1 is 3, 3 to the 6, 9, 12, 18, and this one. On this right hand side, multiples of 5. 5, 10, 20, 25, 30, 45, 50, 55. And this middle here, this is common multiples of 3 and 5, 15. So 15 is multiples of 3 as well as is 5. Similarly 30. Similarly 45, 60. Let us see what is this meaning of common multiples. Multiples are numbers created by multiplying the given number by integers. The multiplication table shows the multiples of the given number. Common multiples are those multiples that are shared by two or more different numbers. For example, let us consider 6 and 8. Multiples of 6 are 6, 12, 18, 24, 30, 36, 42 and so on. Multiples of 8 are 8, 16, 24, 32, 48, 56, 64 like that. Here, both 6 and 8 have some common multiples. For example, here, if you consider the 24 here, 24 is there in this multiples of 6 as well as multiples of 8. Similarly, 48. 48 is present here as well as here. And definitely many more. So these are known as this common multiples of 6 and 8. Let us see the common factors. Factors means a number must divide completely, leaving no remainder, to be a factor of any other number. In other words, we can also say that the divisor is a factor of the dividend if this number is exactly divisible by any other number, leaving no remainder. For example, let us take the number 36. So here, 36 we can write as factors of, can you write as 2 into 18? Similarly, we can write it as 2 into 9. Similarly, 2 into 3 into 3. So here, the factors we can write it as 2 into 18 as a 1. Similarly, 3 into 4, 12 as a 1. Similarly, 4 into 9 as a 1. And 6 into 6 as a 1. So these are the factors. Let us take two numbers, 35 and 42. So factors of 35 are 1, 5, 7 and 35. Factors of 42 are 1, 2, 3, 6, 7, 14, 21 and 42. Both for 42 and 35, we have this common factor such as here 1 and 7 is present in this both the factors. So these are called as common factors of 35, 42. In table 1, there is anything common which is shaded. Here you can consider. Here, 1 is shaded. 33, 36, 39, 42, 45. Yes, we can observe these are multiples of 3. So 3 11s are here, 3 12s are, 3 13s are, like that. Second question. Is there anything common among the circle numbers? If we observe circle numbers 32, 36, 40, these are multiples of 4. Here 4 8s, this one is 4 9s, here 4 10s, so on. Then third question. Which numbers are both shaded as circle? Here, if we observe this one, both shaded as well as a circle. So 36 as well as 48. Similarly 60. So these are the both shaded in the circle. These are the both factors of 3 as well as 4. Let us see question number 1. Find all multiples of 40 that lie between 310 and 410. Solution. The multiples of 40 that lie between 310 and 410 are 320, 360 and 400. Second question. Who am I? I am a number less than 40. One of my factors is 7. The sum of my digits is 8. Second question. I am a number less than 100. Two of my factors are 3 and 5. One of my digit is one more than the other. First let us see first one. It is clearly given that the number is less than 40 because I am a number less than 40 here. Okay. And one of its factors is 7. So this 7. So let us write this factors multiples of the 7 which are less than 40. 7, 7 2 is a 14, 7 3 is a 21, 7 4 is a 28 and 7 5 is 35. If we say 7 6 then it will be 42 which violates this rule which is less than 40. So we consider it 35. Next, the sum of the digits is 8 in the given. So if we observe here only single digit 7, 4 plus 1 5, 2 plus 1 3, 2 plus 8 10, 3 plus 5 is 8. So therefore among these numbers only 35 has a digit sum as 8. Therefore the answer is 35. Second question. It is given that the number is less than 100 and its factors are 3 and 5. The multiples of both 3 and 5 are less than 100 are 15, 30, 45, 60, 75 and 90. Among these numbers, only one digit, one difference between the two digits one means, for example, 5 minus 1, 4, 3 minus 0, 3, 5 minus 4, 1, 6 minus 0, 6, 7 minus 5, 2, 9 minus 0, 9. So only it has this, for the 45, the difference between the two digits is 1. Therefore, the number is 45. Question number 3. A number for which the sum of all its factors is equal to twice the number is called as a perfect number. So here they are giving the definition of the perfect number. The number 28 is a perfect number. Its factors 1, 2, 4, 7, 14 and 28. Their sum is 56 which is twice 28. So find a perfect number between 1 and 10. So there is only one perfect number between 1 and 10 which is 6 because the factors of 6 are 1, 2, 3 and 6. So the sum of the proper factors excluding 6 is 1 plus 2 plus 3. This means 6. So since the sum is equal to this number itself, 6 is a perfect square. Perfect number. The number 6 is the only perfect number between 1 and 10. Figure it out. Find the common factors of 20 and 28, 35 and 40, 4, 5 and 12, 5, 15 and 25. Solution. Let us see first question 20 and 28. Factors of 20 are 1, 2, 4, 5, 10, 20. Let us consider this as equation 1. Second one 28. Factors of 28 are 1, 2, 4, 7, 14, 28. Among these 1 and 2, what are the common factors we have? We have 1, 2. 1 is there in the board series, then 2, then 4. Therefore, the common factors for the 20 and 28 are 1, 2 and 4. Let us say B subsection 35 and 50. Factors of 35 are 1, 5, 7 and 35. Let us consider this as 1. Similarly, factors of 50 are 1, 2, 5, 10, 25, 50. Comparing 1 and 2, the common factors of 35 and 50 are 1 and 5. Let us see C, subsection C, 4, 8 and 12. Factors of 4 are 1, 2, 4. Factors of 8 are 1, 2, 4, 8. Factors of 12 are 1, 2, 3, 4, 6, 12. So, therefore, from 1, 2 and 3, common factors are 4, 8 and 12 are 1, 2 and 4. Similarly, 5, 15 and 25. Let us consider 5 common factors of this one as 1 and 5. Factors of 15 are 1, 3, 5, 5, 15. Common factors of 25, 5, 15, 25 are 5, 15, 25 are 1 and 5. Let us see question number 5. Find any three numbers that are multiples of 25 but not multiples of 50. Three numbers that are multiples of 25 but not multiples of 50 are 75, 125 and 175. 75 can be written as 25 into 3, but not multiple of 50. Similarly, 125 can be written as 25 into 5, but not multiple of 50. 175 can be written as 25 into 7, but not multiple of 50. Sixth question. Anshu and his friends play Idli-Vada game for the numbers which are both smaller than 10. The first time anybody says Idli-Vada is after the number 50. What could be the numbers which are assigned Idli and Vada? Here, let us say Idli-Vada is said to be after 50. So the LCM of two numbers A and B are 50. And A and B should be less than 50. Let's try for the pairs of A and B, which are both should be less than 10 and then LCM should be greater than 50. So if you consider 7 and 8, LCM is 56. So for this one, we can say Idli-Vada. Similarly, 7 and 9, LCM is 63, which is greater than 50. Similarly, for 8 and 9, LCM is 72. So these are the valid answers for the question. So the possible answers, the numbers could be 7 and 8 or 7 and 9 or 8 and 9. Let us see question number 7. In the treasure hunting game, Grumpy has kept treasures on 28 and 70. What jump sizes will land on both the numbers? In the treasure hunting game, if the Grumpy has kept measures on 28 and 70, then the common factors of 28 and 70 will be the jump sizes to land on both the numbers. Factors of 28 are 1, 2, 4, 7, 14, 28. Factors of 70 are 1, 2, 5, 7, 10, 14, 35 and 70. So from 1 and 2, common factors of 28 and 70 are 1, 2, 7 and 14. Question number 8. In the diagram below, Guna has erased all the numbers except the common multiples. Find out those numbers could fill missing numbers in the empty regions. So this is where this Guna has removed multiples of dash, but it has kept this common multiples. Okay. The possible pair of this numbers whose common multiples include 24, 48 and 72 is 6 and 8. Okay. Here we can write, here this one is 24 is 6 and 4 or 8 and 3. Similarly, 48 also, thus these are the multiples of this one. So if we observe 6 and 8, multiples of 6 are 6, 12, 18, 30, 36, 42, 54, 60, 66. Similarly, multiples of 8 are 8, 16, 32, 40, 56, 64, 80. The common multiples of 24, 48, 72. This is multiples of 6 and 8. Nothing but common multiples in. Let us see question number 9. Find the smallest number that is a multiple of all the numbers from 1 to 10 except for 7. The smallest number that is a multiple of all the numbers from 1 to 10 except 7 will be the least common multiple of these numbers, LCM. For example, let us take 1, 2, 3, 4, 5, 6, 7 we are not including because 7 is excluded, 8, 9, 10. When we are taking this common factor as a 2, so we'll get it as 1, 1, 3, 2 because 2 1s are 2 2s are 4, 2 3s are 6, 2 4s are 8 and 2 5s are 10. Similarly, among this one again we can take this common factor as a 2. So we are taking, then we'll get as 1 1 3 1 5 3 2 9 5. Now we can take 3 as this factor. 1 1 1 5 1 2 3 5. Next, among this one common factor we can take it as 5. The numbers leading to 1 1 1 1 2 3. So there are no other common factors. Therefore, LCM of this one will be 2 into here, 2 into 2 into 3 into 5 and 2 into 3. So 2 into 2 into 3, 5, 2, 3. The number is 360. So the smallest number that is the multiple of all the numbers from 1 to 10 except 7 will be 360. Question number 10. Find the smallest number that is multiple of all the numbers from 1 to 10. In the previous number, they have excluded one number. Here, we are including all the numbers. So, the smallest number that is multiple of all the numbers from 1 to 10 will be the least common multiple of these numbers. So, we are writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we are taking this common factor 2 first. So, 1, 2 ones are 1, then 3, 2 2s are 4, then 2 3s are 6, 2 4s are 8, and 2 5s are 10. Again, if we observe here, 2 is we can consider 1 1 3, 2 1s are 2, 5 3 7, 2 2s are 4, 9 5. Again 3 we can consider here. This is 3 factors. So 1 1 1 1, 3 3s are here. Then we can consider the 5 also a factor here. Next 1 1 1 7 2 1. So here there is no common factor between 7 2 3. All are prime numbers. Therefore, the multiplication of this number 2 into 2 into 3 into 5 into 7 into 2 into 3. This is 2520. So the smallest number that is a multiple of all the numbers from 1 to 10 except 7 will be 2520. Thank you.